Hey champignons, gonna finish this series with one more sneaky video of mixed examples. Okay, the first one we've got here is 3x over y to the power negative 3 all squared. We're multiplying that by x to the power negative 5 over 6y squared. Cool. Now, as per previous examples, I'm going to start by getting rid of the brackets that are presented to us. So I've got to raise everything in this bracket to the power 2. So 3 squared is 9. X to the power 1 squared is x squared. And then on the denominator, we've got y to the power negative 3 times 2, which is negative 6. And I'm multiplying that by x to the power negative 5 over 6y to the power 2. Cool. Okay, so now I'm going to make everything positive. So 9x squared multiplied by y to the power 6. And I've nothing on the denominator now, but to make it easier while we're dealing with fractions, I'm just going to say that's over 1, because that's not going to change our value of that at all. For our second one, similarly, there's going to be nothing left in the numerator, so that's going to become 1 over 6 x to the power 5, y to the power 2. And now, friends, it's time for a bit of a cancel party. So I'll scroll down, otherwise I'll be drawing over my face a little bit. So we've got 9 divided by 6 gives us 3 over 2. X to the power 2 divided by x to the power 5 is going to give us x to the power 3, but in the denominator. And then y to the power 6 divided by y to the power 2 is going to give us y to the power 4 in the numerator. So all up, that's going to leave me with 3y to the power 4 over 2x to the power 3. Lovely. And hopefully by this point you're starting to get a bit of a rhythm to doing these. There is a rhythm to solving these sorts of problems, so I'm hoping that you're finding that's where you're at with these ones. Okay, similar story with the next one. I'm going to start by removing the brackets. So I've got 3 multiplied by, and then in brackets, a to the power 2, b to the power negative 4 all squared. So if I get rid of that bracket, I'll have a to the power 2 times 2, which is a to the power 4. b to the power negative 4 times 2, which is b to the power negative 8. And again, I'll get rid of the bracket on the bottom. 2 to the power 2 is 4. And then I'll have a squared and b to the power 4 as well. I'm going to do 2 things here just to save me a line of working out. I'm going to flip the second fraction and multiply to get rid of that divide sign, but I'm also going to get rid of the brackets on the other side as well. So if I'm flipping that over, 3 squared becomes 9, a to the power negative 2 squared is, well, then multiplied by 2 is a to the power negative 4, and then b to the power 1 times 2, and then that's all over a to the power negative 2 and b to the power negative 2. Okay, now I'm going to make everything positive, so 3a to the power 4 over 4a squared, and then b to the power of 4 plus 8, which is going to be b, because the b to the power negative 8 will come down here and become positive. So then have b to the power 4 multiplied by b to the power 8, which will give me b to the power 12 for that one. And I'm multiplying that by a to the power, bring this one up here, a squared, bring this one up here too, multiply that by b squared, and, oh, actually, I already have a b squared up there, so that's actually going to be, I'll reach past my microphone to delete, b to the power 4 for this one. And then I'm going to put my a to the power negative 4 on the bottom and make it a to the power positive 4. All right, now it's time for another cancel party. A to the power 4 and a to the power 4 cancel straight away. That's great. A squared and a squared cancel. That's also great. B to the power 4 and b to the power over b to the power 12, that's going to cancel to b to the power 8. So what I'm going to have there is 3, and this is where I normally cancel my coefficients as well, but 3, 4, we can't divide 3 by 4, we can't divide 9 by 4 either, so we'll multiply the 3 and the 9 together. 27 is going to be on the numerator, and then 4b to the power 8 in the denominator. Lovely. So these start by looking a bit full on and scary, but they're actually not too bad if you can work through them methodically. For me, working through in such a way where I get rid of the brackets, make everything positive, and then have a big cancel party, that works pretty well for me. Okay, for the next one, express in index form. So remember, for these ones, we want to take something that's got a root sign in there and get rid of all of them. So here we've got the square root of 10 multiplied by x to the power 3. It's a square root because there's an invisible 2 just there. So another way of writing that is 10x cubed, but we're raising the whole thing to the power a half for this one. So if I rewrite that as 10 to the power a half, because really I've got a 10 to the power 1 here, and 1 multiplied by a half is a half. Similarly, 3 multiplied by a half is going to give me 3 over 2. So then x to the power 3 over 2 is going to give me my answer just here. I'm going through these a bit more quickly because we covered these in previous videos. This is more of a nice, fun conclusion. So similarly here we've got 2a to the power 9 multiplied by b, and we're raising all of that to the power 1 over 3 because we're finding the cube root. So expanded, this would be 2 to the power 1 over 3, a to the power 9 times a third, which is a to the power 3, and then b to the power 1 over 3 as well. Again, looks a bit scary, but it's not so bad once you get nice and methodical with it. I've included this one because it's a bit of a funny one. Here we've got 4 multiplied by the cube root of 4. So what I'll do for this one is say, well, that's the same as saying 4 multiplied by 4 to the power 1 over 3, which is kind of like saying 4 to the power 1 multiplied by 4 to the power 1 over 3. So using our very first index law that you would have learned a couple of years ago, we can simplify those powers by adding them together. 1 plus 1/3 is going to give you 4 over 3 for this one. So 4 multiplied by the cube root of 4 is the same as 4 to the power 4 over 3. Very good. Okay. A couple of evaluate without a calculator questions here. So for these ones, we see the word evaluate, we need to get an actual value for this one. So really you've got to just know if you've given a fractional power, you've just got to know how you convert it to a square root or a cube root or something like that. So for example, 64 to the power 1 over 3 is the cube root of 64, which is 4, because 4 times 4 will give us 16 and times 4 again will give us 64. The next one's a little bit funny. We've got 1 over 8 and we're finding the cube root of the whole thing. What I'll remind you of here is that's the same as saying we're finding 1 to the power 1 over 3 and dividing that by 8 to the power 1 over 3. Again, that's some knowledge from index laws from previous years that you're carrying on. Now, the number that we multiply by itself 3 times to give us 1 is just 1, because 1 times 1 times 1 is still 1. And then the cube root of 8 would be 2, because 2 to the power 3 gives us 8. So 1 over 8 to the power 1/3 just simplifies to a half, so that's nice and easy. Okay, and the last one, 125 to the power negative 1/3. That'll be the same as 1 over 125 to the power 1/3, which is the same as saying the cube root of 125, which will be 1 over 5. Very good. Okay, the last question that I've included here is very spicy. So this might be beyond what you can do at the moment, but I wanted to include this just to show that once you've got the hang of these index laws and you can do all these simplifying and conversion questions, what about if you've gone on to learn about factorizing and then you're given a question that's a bit like this? So you can shut off the video now if you're still here, or you can carry on for interest's sake if you want to. I don't really mind, it's your life. So here we've got an expression, it's 4 to the power x plus 1, and it's equal to 2 to the power x squared. So we're raising a power to another power for this one. But the actual question is find algebraically the exact value of x if 4 to the power x plus 1 equals 2 to the power x squared. And we've got to justify that with an answer, or with our working out, I suppose. Okay, what I'm going to do here, I'm going to start by writing out the expression. So 4 to the power x plus 1, and that's equal to 2x squared. Okay, what I'll do next is say, well, 4 is the same as 2 squared. And the reason I'm putting that there is at some point I'm going to want to have 2 to the power something on the left-hand side and 2 to the power something on the right-hand side, and I'll show you why in a moment. So I can rewrite 4 to the power x plus 1 as 2 squared to the power x plus 1. And that's equal to 2x to the power 2, like this. Okay, so now if I do a little bit of using my prior knowledge of index laws here, I'm going to rewrite that as 2 to the power 2 bracket x plus 1, and that's equal to 2x to the power 2. Okay, so this is where we've used a little bit of trickery to turn it into a different sort of question. So if these two are equal to each other, 2 to the power something equals 2 to the power something else, we can say that those powers are going to be equivalent expressions. So 2x plus 1 is equal to x squared. Beautiful. Well, it's not that beautiful just yet. We've not actually answered the question. So we've got to do a little bit more to keep going. What I'll do now is expand the bracket on the left. So 2x plus 2 is going to be equal to x squared. Okay, now I'm going to combine this with my knowledge of factorizing. And again, you might not be here just yet, but you know, you can still watch for fun. What I'm going to do now is put everything on the right hand side. You can put it on the left, it'll be the same, and just make it equal to 0. So now I've got x squared, so 0 is equal to x squared, take 2x, take away 2. So I've taken the 2x and the 2 from the left, which means I have to take it away from the right as well. So now what I'm thinking is if I can factorize this expression on the right, I'm going to be left with a value that, well, not with a value, I'm going to be left with an expression that I can make equal 0 and then find the answer to the question. So for this one, I'm going to look at this and think, well, how can I factorize this? I can't use monic factorizing the normal, easy way because I've known numbers that add to give me -2 and multiply to give me -2 as well. I obviously can't do difference of 2 squares. I can't do grouping, but what I can do is complete the square for this one. So what I'm going to do is say x squared, take away 2x. I'm going to half that 2 and square it and then add that on. So that's plus 1. And then to keep the expression the same value, I'm going to take that 1 away and then bring down the take away 2 from above just there. Now simplifying this, I can factorize this component of the expression. So x squared take away 2x plus 1. That's going to leave me with x take away 1 squared. And then take away 1, take away 2 at the end. So I'm going to have x take 1 squared take 3. Now what I'm going to do is use a technique where I force the take 3 to be a difference of 2 squares type problem. So I'm going to rewrite that as x take away 1 squared, take away the square root of 3 squared, which enables me to use difference of perfect squares. So then I'll have an answer of x take 1, take away the square root of 3, and then x take 1 plus the square root of 3. Running out of space here. Okay, so here I'm going to say, therefore, because of the null factor law, the values that I could use on the right-hand side to make x equal 0, I could have 1 plus the square root of 3, or, x equals 1 plus the square root of 3, or we could have x equals 1 subtract the square root of 3. You'll often see that written as x equals 1 plus or minus square root of -3 like this. Remember, our question was asking for an exact value of x, so it's not weird that our answer looks a little bit strange. If we're finding exact values, that's what, that's the sort of thing that comes out there. So even if you haven't completed any factorizing at that sort of level, don't worry, that'll be coming up in your course, I'm quite sure. But I just wanted to give this as a little preview to say, when you have that mastery of index laws, it's not just about, taking a, like a simplifying question or a converting to and from like surd form or index form. You might be required to combine your knowledge of index laws as well as something else as well.